Imagine discovering hundreds or even thousands of prehistoric bones buried in one place. Was it a catastrophic flood, a deadly drought, a dinosaur stampede, or did those animals die centuries apart? Today we're investigating the mysterious world of mass fossil graves. All right, let's see how sharp you really are. 10 questions. No hints, no second chances. I'll give you the statement. You decide, fact or fiction? Think fast, trust your instincts, and keep score, because a pile of bones is not always what it appears to be. Ready? Let's test your knowledge. Question 1. Here's your first statement. When many dinosaur skeletons are discovered together, it means all of those dinosaurs died in the same catastrophic event. The answer is fiction. This sounds logical, but a concentration of fossils does not automatically represent a single mass death event. Bones can accumulate in one location over decades, centuries, or even thousands of years. Rivers may repeatedly transport carcasses and loose bones into the same channel, floodplain, or low-lying area. Paleontologists call this kind of mixed accumulation a time-averaged assemblage. To determine whether the animals died together, scientists examine the sediment, preservation, skeletal positions, weathering, species composition, and whether the fossils came from one distinct layer. A mass of bones can record one terrible day, or an extremely long sequence of unrelated deaths. Question 2. Next statement. Mass fossil grave is the precise scientific term paleontologists use for every large concentration of prehistoric bones. The answer is fiction. Mass fossil grave is a dramatic and understandable description, but scientists usually use more precise terms. A bonebed is a layer of rock containing an unusually dense concentration of bones. A mass mortality assemblage specifically represents multiple animals believed to have died during the same event or within a very short period. That distinction is important. Every mass mortality assemblage may form a bonebed, but not every bonebed proves that its animals died together. Before calling something a mass death site, paleontologists must first reconstruct how the remains reached that location. Question 3. Let's continue. A bonebed dominated by one dinosaur species can provide evidence that those dinosaurs gathered in groups. The answer is fact. When many individuals of the same species are preserved together, especially when they include similar ages or sizes, it can suggest that the animals were together before they died. They may have been migrating, feeding, nesting, seeking water, or traveling as a herd. But scientists must be careful. Water currents can sort and concentrate similar-sized bodies. A particular habitat may also have attracted the same species repeatedly, producing a bonebed without proving permanent social behavior. So a single species bonebed can support the idea of group living, but it does not prove that the animals maintained complex social herds throughout their lives. Question 4. Pay attention to this one. Mass fossil graves were created almost exclusively by enormous floods. The answer is fiction. Floods can kill animals, transport bodies, and bury remains rapidly, but they are only one possible explanation. Mass death events may also be caused by severe drought, poisoned or oxygen-starved water, volcanic activity, disease, wildfires, collapsing dunes, mud traps, or animals becoming trapped around a disappearing water source. In some cases, the event that killed the animals was different from the process that buried them. A drought might cause the deaths, for example, before a later flood covers and preserves the remains. A bonebed can therefore contain evidence of several different chapters: gathering, death, decomposition, transportation, and burial. Question 5. We're halfway there. Finding complete articulated skeletons together can indicate that the animals were buried relatively quickly. The answer is fact. An articulated skeleton still has many of its bones preserved in their natural anatomical positions. After an animal dies, decomposition, scavengers, weather, and moving water usually begin separating its skeleton. If numerous animals remain largely connected, their bodies probably experienced limited disturbance before burial. This could happen when animals become trapped in mud, are covered by sediment during a sudden flood, or are rapidly buried by another event. However, articulated fossils do not tell scientists the entire story by themselves. Paleontologists must still investigate what killed the animals, how long the carcasses were exposed, and whether burial happened immediately or after a short period of decomposition. Question 6. Let's raise the difficulty. The direction and arrangement of bones can reveal whether water transported them before burial. The answer is fact. Moving water can leave clues inside a bone bed. Long bones may become aligned with a current. Lighter or easier to carry bones may be transported farther than heavy skulls and dense limb bones. Rounded edges, abrasion, and separated skeletal elements can also indicate movement. Scientists study this process through taphonomy, the investigation of everything that happens to an organism between death and discovery. If bones of similar size are concentrated together, that pattern may have been created by flowing water rather than animal behavior. A fossil site is not simply a collection of bones. It is a crime scene written in geology. Question 7. This one catches people off guard. If a mass fossil grave contains mostly predators, it proves those predators hunted together in packs. The answer is fiction. Several predators preserved together can be intriguing evidence, but it does not automatically prove cooperative hunting. Predators may independently gather around a trapped animal, a carcass, or a shrinking water source. They might also become caught in the same natural trap at completely different times. Water can transport their remains into one location, and repeated deaths can create an apparently dramatic gathering that never existed in life. Scientists need supporting evidence, such as trackways, age patterns, repeated associations, and detailed geological context, before proposing pack behavior. Multiple predators in one bone bed may represent a social group, a feeding frenzy, a deadly trap, or thousands of years of accumulation. Question 8. Stay focused. The ages of the animals in a bone bed can help scientists reconstruct what the group may have been doing before it died. The answer is fact. Paleontologists can estimate dinosaur ages by studying body size, bone development, and microscopic growth patterns. A site dominated by juveniles might represent a group of young animals traveling together, a nursery population, or individuals especially vulnerable to a particular hazard. A mixture of juveniles and adults could suggest a broader social group, or simply a location visited by animals of every age. In Mongolia, groups of similarly sized juvenile protoceratops have contributed to discussions about age-based aggregation. But age patterns must be interpreted cautiously. Preservation and transportation can selectively remove certain body sizes, changing the population that scientists eventually discover. Question 9. Almost there. A single bone bed can contain fossils produced by both a sudden mass death event and slower accumulation over time. The answer is fact. This is where fossil sites become especially complicated. One layer may contain animals killed during a single event, along with older bones already lying in the surrounding landscape. A flood can collect those older remains, combine them with newly killed animals, and bury everything together. Scientists may identify this mixture through different levels of weathering, abrasion, mineral staining, and preservation. Some bones may be fresh and articulated. Others may be broken, worn, or scattered. The resulting bone bed does not preserve one perfectly frozen moment. It can combine multiple moments into one geological deposit. Question 10. This is the final question, and it's the one that surprises most people. A mass fossil grave provides a complete and unbiased picture of every animal that lived in that ancient ecosystem. The answer is fiction. A bonebed may look like a perfect census of a lost world, but fossilization is highly selective. Animals living near rivers, lakes, and floodplains generally had a better chance of being buried than animals living in environments where bodies decomposed without sediment. Large, durable bones are more likely to survive than delicate skeletons. Tiny animals may disappear completely. Scavengers can remove body parts, currents can sort bones, and acidic conditions can destroy remains before fossilization begins. Even the most spectacular mass fossil grave represents only the organisms that died in the right place, experienced the right conditions, and survived every stage between death and discovery. The fossils we find are not the entire prehistoric world. They are the rare survivors of an enormous filter. And that is the biggest lesson of mass fossil graves. A crowded bonebed can reveal an extraordinary story, but only when scientists understand what the grave has hidden as well as what it has preserved. All right, how did you do? Drop your score in the comments. Be honest. Did you recognize the difference between a true mass death site and a bonebed assembled over thousands of years? 8 or more? You're ahead of most people. 10 out of 10? You've earned the title of fossil detective. Less than that? Now you know what others don't. Hit like, subscribe, and share this challenge with someone who thinks they know dinosaurs. And come back for the next fact or fiction challenge from Meet the Dinosaurs. Because every fossil holds a clue. But the first explanation is not always the correct one. Knowing more is how you stay ahead.